Solving quadratic equations with complex solutions. Find the roots in simplest a plus bi form. So simplest a plus bi form is your clue that you should be using the quadratic formula. And the reason being that the other option for solving a quadratic equation is to factor. When we factor, we don't get imaginary numbers or a plus bi form. So anytime I see a plus bi form, a light bulb should go off in my head, and I should know that I have to use the quadratic formula. So I'm going to identify my a, b, and c values. Remember, those are, if you're in standard form, alphabetical order going across. So my coefficient for x squared is 1, that's A. My coefficient for x is -6, that's B. And my coefficient for C is 13, or that's your constant. There is no variable. Remember, your quadratic formula is given to you. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So on a test, a quiz, the Regents, a midterm, a final, anything like that, you don't need to memorize this. It will be given to you. So I'm going to start by setting up my parentheses anywhere I see a variable, so that way I can go right ahead and substitute in. So I have -6 for B, I have 1 for A, and I have 13 for C. Remember that underneath the radical is what we put into the calculator, exactly as you see it. So I am going to open up my calculator. I'm going to move it over here so you can see both. In the home screen, open parentheses, -6, close parentheses squared, -4 times 1 times 13. We get -16. So a -6 gives me a +6 plus or minus the square root of -16 over 2. Now, earlier in this lesson, you should have learned about negative numbers under the radical. Because -16 is a perfect square, I don't need to break it down. The square root is going to be 4i. If you're not sure, you can use your calculator. Second square root, -16. If you're still getting this error, you haven't put your calculator in a plus bi form. So I'm going to exit out of it, mode, make sure you're in, not real, a plus bi. I'm going to go back to my home screen. Here's my square root of -16, and we get 4i. Remember, if it wasn't a 16, if there was another number that was not a perfect square, we would have to break it down. So I have x equals 6 plus or minus 4i over 2. At this point, once you've simplified your radical, you can cancel anything that divides by the same number. These all have a GCF of 2, so this becomes a 1, this becomes a 2, and this becomes a 3. So in simplest form, this is x equals 3 plus or minus 2i. Now part B says, what do you think the graph will look like and why? Confirm by graphing it on the calculator. So hopefully you realize that these are imaginary solutions. And imaginary solutions, we talked about with polynomials, do not touch the x-axis. So there should be no x-intercepts, since the roots or solutions, they're the same thing, are imaginary. And we can confirm that on our graphing calculator by going to the y equals, and I'm going to clear out what I have here, and I'm going to type in my original function, x squared minus 6x plus 13. Hit my graph, And you should see there are no x-intercepts. If you want, you can put a sketch of it on your paper so that way you have it to study from, and that way you know what it looks like.